This is CES 50, Harvard University's Introduction to the Intellectual Enterprises of Computer Science and the Art of Programming. And my name is David Malan, and I was just set in with this first language. Do we have an opportunity to start to take for granted after today some common vocabulary and idea? And we'll do this by way of the course's first languages. In addition to C and Python and JavaScript and SQL and HTML and CSS, well, we focus initially and just for problem set 0 on this graphical language called Scratch, developed by MIT's Media Lab down the road to help students and kids especially express themselves algorithmically in a way more consistent with what we might call computational thinking. And it's a useful language because very quickly next week in week 1 do we transition to a more traditional, if arcane language called C, which is purely textual. You'll only use your keyboard in order to write instructions like these on the screen. But even if you've never seen a programming language before, in just glancing at this, albeit cryptic, you can probably guess that probably prints hello world, but there's a lot of syntactic overhead there, right? There's the weird hash symbol or hashtag up top. There's the angled brackets, some parentheses, curly braces, semicolon. There's just so much visual syntax that gets in the way. We start the course with Scratch so as to get past all of those intellectually uninteresting distractions and focus instead on the ideas. In fact, this might be before, this for this week shall be after. This in this graphical language, Scratch, is how you would implement that same program. A program that when run simply says hello world. And what's nice about Scratch is that it's this graphical programming environment that uses puzzle pieces or blocks that only interlock together if it makes logical sense to do so. And with Scratch, can you develop animations and interactive games and art and any number of things that you might imagine in your own mind and implement them simply by dragging and dropping puzzle pieces. And indeed, we'll have the ability to express some of the same ideas that I just mentioned a moment ago in the context of Mike Smith in searching a phone book. Things like functions, just actions. Things like loops that do things again and again. Variables, which is something we'll introduce, but it's familiar perhaps from algebra. Just some kind of placeholder to store some value you might need later. Boolean expressions were those yes, no, or true, false questions from before. Conditions are those forks in the road, those branches, so to speak. And then there's some fancier features we'll see even today called arrays and threads and events that we'll then revisit over time in different languages, but Scratch allows us to explore all of these. So here in Scratch, this purple block is what a function is typically going to look like. This purple puzzle piece that has some word like say, which is the action, and then it might have an argument or a parameter, some way of kind of customizing what that block does so that it's not predetermined by MIT what this purple block says. In fact, you'll see in a moment that I'm able to type the words like hello world or hello David or hello Zamila, whatever I want, in the argument to that puzzle piece, the white box there. Meanwhile, if I want a loop, we'll see that there's puzzle pieces that look a little orange like this, and their shape kind of suggests that something happens again and again in a cycle. So if I wrap a say hello world block with a forever block in Scratch, it's just going to keep saying hello world forever, quite literally. Meanwhile, there's another type of loop in Scratch that we'll see, a repeat block, where if you know in advance how many times you want the loop to execute, a finite number of times, in fact, you can specify that by typing in a number or even plugging in a variable like x or y, as we'll see. In fact, variables like I in this case, which is a common name for an integer variable that just stores a number. An integer might be to use this orange block here to set a variable like I to 0. Here's an example in green of a Boolean expression in Scratch. Even though this looks like a math formulas pretty, or math inequalities like this really are Boolean expressions. This is either true or false. I is less than 50. It's either a yes or no answer, or a true or a false answer. And we'll generally call those Boolean expressions. And it doesn't have to be 50. It can be x less than y, greater than y, equal to y. Any number of other questions might be asked. Now, at first glance, this might look suddenly quite bulkier, and it is. But concept-wise, it's pretty familiar from before. If x is less than y, then say as much. Else, if x is greater than y, then say as much. Else, say x is equal to y. So we have an example there of a third scenario, the only third possibility. X is either greater than, less than, or equal to. So we have a three-way fork in the road. And notice what's cool here. Scratch, it would seem, has just one puzzle piece, in this case, an if-else block. And yet that would seem to imply you can only have a two-way fork in the road. You can go left or right. But what about that third scenario? What if x equals y? No big deal. Take one puzzle piece, put another one inside of it to create the semantic equivalent of if, else, and now you have your three-way fork in the road. And as we'll see, the Scratch puzzle pieces can be stretched and grow so as to cram more stuff in them. You don't have to fit everything in its default size. This is something we'll soon see is called an array. It's like a list, some way of storing multiple pieces of information in a variable, not just a number. These we'll see are representative of something called multi-threading. In fact, all of your Macs and PCs these days support multi-threading, which means you can literally do multiple things at a time. You can have Microsoft Word up in the foreground working on some essay. You might have a browser in the background opening Gmail or Facebook or the like. Your computer can do multiple things today because it is multi-threaded, and programs therein in particular are also multi-threaded. There's things called events as well in the world of Scratch, and then there's a way too to make our own custom puzzle pieces if things don't actually exist in advance. So let's motivate this as follows. Some years ago, when I first discovered Scratch, when I was actually a grad student at MIT, we ourselves were tasked to make homework, and I implemented, which in retrospect was a very poor decision because it's the most infuriating song in the world to listen to for 8 hours while working on your homework, but something I called Oscar Time, with perhaps a familiar song. CS50's own Jordan Hayashi, one of our more senior staff members, has upgraded it for 2015 and now 2016, since back in the day I had everything just going into Oscar's trash can. Now we support recycling and composting. But to paint the picture of what we can do here and to motivate some of the lower level examples, could we get one other volunteer to just come on up and play my first homework assignment ever? Come on up. What's your name? Henry. Come on up. So come on up. Let's head either way. And you'll see in a moment, I'm going to go ahead and hit the green flag in the top right-hand corner, which means go. The little stop sign icon is going to say stop, and that's how you stop and start and stop the program. Nice to meet you. Nice to meet you. All right, so we're going to see the instructions on the screen in just a moment. And just by playing this game for a few seconds, trust me, we're not going to want to play all the way to the end, you will get a sense of what the program does. And more than just focus on Henry being good or bad at this game, focus on how was it implemented by me originally and then by Jordan. In other words, where are the variables? Where are the loops? Where are the functions? And we'll see if we don't see those underneath the hood. Close the drag track to the appropriate band.
Oh, I love trash. Anything dirty or dingy or dusty. Anything ragged or rotten or rusty. Yes, I love trash. If you really want to see something trashy, look at this. I have here a sneaker that's tattered and worn. It's all full of holes and the laces are torn. A gift from my mother the day I was born. I love it because it's trash. Oh, I love trash. Anything dirty or dingy or dusty. Anything ragged or rotten or rusty. Yes, I love trash. Here's some more rotten stuff. I have here some newspaper, 13 months old. I've wrapped this inside it. It's smelly and old, but I wouldn't trade it for a big pot of gold.
So just imagine debugging that program if there's like a problem like 2 minutes into the song. But so what's going on here really? As complicated as it might start to seem to get over time, indeed more and more stuff started falling, what's interesting about this kind of example, and we'll see a few others, is that if you look past the complexity or the sort of sophistication of the game, there's very simple building blocks at play, all of which, if you distill them to those building blocks, are very accessible and implementable unto themselves. For instance, it's been some time, but I'm pretty sure what I initially did when making this game for the first time was I completely procrastinated. I didn't focus at all on the logic or the puzzle pieces. I focused on the graphics and finding the street post and the trash can and all of that. But those were requisite ingredients at first. And once I'd finished procrastinating, laying out the sort of overarching framework, I decided, let me just make one piece of trash fall from the sky. And we'll see Scratch supports things called sprites, characters that can have different costumes on, so they look different. And so I put a trash costume on one such sprite. And I just needed it to fall from the sky. And so it turns out Scratch, like most programming languages, supports random numbers, or technically pseudo-random numbers, so that by dragging and dropping certain puzzle pieces, I was able to have the trash come from the left at first. And then the next time it fell from the right, and then from the middle. And all the game did was just have trash falling from the sky. You couldn't point at it or click on it. You couldn't open the trash can. You couldn't do anything. But it was a baby step toward my ultimate vision. And after that, I actually implemented some kind of sensing so that if you did click and drag on the trash, on the piece of trash over the trash can, can, Oscar's lid would open and close. Nothing would happen to the trash, but at least the lid would open and close. So then check, step 2 of 2. And this is what's going to be key in both problem set 0 and in programming more generally, is to take these very deliberate baby steps, because not only does it allow you to feel, honestly, accomplished much more quickly. It's the worst thing in the world to try to implement all of Oscar time, then hours later hit the green flag, and nothing works as expected, because where do you even begin to debug or to troubleshoot that program? It's just overwhelming. And so truly embracing this idea of taking steps, baby steps, again and again, building up something that's in the end really impressive and complex, but at first is not nearly as much so. In fact, let's do this. Let me go ahead, and Scratch itself exists on the web at scratch.mit.edu, and you'll be told as much again in problem set 0, the specification for which is already on CS50's website. But this is what Scratch itself is. And there's really just 3 primary areas. At the top left there is the so-called stage. This is Scratch. The default costume is a cat. And this is the sort of rectangular world in which he can move, up, down, left, right, and some other stuff. In the middle here are our categories, or our palettes of puzzle pieces, and different colors mean different things. And if you poke around, you'll see things like loops and conditions and variables and other ingredients. And then over here is the scripts area. This is where I can drag and drop those puzzle pieces to do things. So let's do one such thing. Let me go ahead and I know where it is, so I'm going to sort of immediately click on where I know things are ready to be. But pointing and clicking and poking around are inevitable. So when green flag clicked, what do I want to do? I'm going to do this. I'm going to drag this purple puzzle piece, say hello for 2 seconds, and let me zoom in. And I'm going to change this to be what I want it to be. Hello world for 2 seconds is fine. Now I'm going to click the green flag, or if I really want, I can full screen it and then come back. But we'll just keep everything in one window. Green flag, hello world. All right, not all that interesting. So let me go ahead and do this. Let me try another one. When green flag clicked, let's do something like a sound. And notice that out of the box for free, you get a cat sound, as is the default sprite. So now let me go ahead and hit the green flag now. Oh, that's adorable. I'm programming, right? So what have I done? This is the equivalent of a program. It's obviously super simple. Didn't really take all that much effort, and MIT did most of the work. But I have called a function. I have used a function. I've made some action using just that one purple puzzle piece. Well, what if I want to do 3 meows in a row? Let me go ahead and do 2 and 3. And notice that when you hover nearby a puzzle piece, a little white line appears sort of magnetically, and they'll snap together when you let go. Let's see what happens here. You know what? There's a bug. I only hear 1 meow. Why might that be? Yeah. Yeah, we don't really hear it, but that's good intuition. They're all playing at the same time. Why? Well, a computer's just going to do what you tell it to do. So if you say play sound, play sound, play sound, but you don't tell it to play until you're done, play until you're done, it's just going to blow through the program really fast and do only what you tell it to do. So I actually need to fix this in a couple of ways. I could just do this, get rid of this, and let me try this other puzzle piece, play sound meow until done, and then drag 3 of these and click play. It's not really very, thank you, very natural. So why don't let me go to control here. Oh, nice. Wait 1 second. And now let me go back to sounds and play sound until done. And then let me wait 1 second. And then let me go and get one more sound. And here we go. A little more natural. But this is not very efficient, right? Like I was getting bored, albeit briefly, sort of clicking back and forth and really duplicating my work, pretty much copying and pasting. And indeed, if I control-clicked or right-clicked, I could have just copied and pasted. What would be a better construct to use? What idea from before? Yeah, so a loop. And in fact, if we poked around, we might find exactly that. Let me go to events, or rather control. So repeat. I don't want it to be 10 times, because that's going to get annoying quickly. But I will repeat 3 times. Let me go back to sound and play the sound until it's done. Let me go back to control and just wait 1 second. And notice, you might think it doesn't fit. But again, if magnetically you let it snap in place, it will grow to fill. Let's hit play now. OK, nice. And this is what would be called a program that's also correct. It meowed 3 times, fairly naturally. But it's better design, right? I'm using less redundancy. I didn't copy and paste anything. I just used a better idea. Now, this is still not all that interesting with Scratch not doing anything. So let's do something else instead. Let's do something forever. And you know what? Motion seems interesting. Let's have him move 10 steps and hit play now. OK. Well, we can kind of drag him back, and he's still running because he's doing this forever. So the loop is doing what it's saying to do, but this isn't all that interesting. Let's do this. Let me add a control block and use one of those conditions for the first time. So it's going to move 10 steps, 10 dots, 10 pixels on the screen. Then it's going to ask this question. If something is true, then do something inside this block. So you know what? It turns out sensing has a whole bunch of Boolean expressions, questions of the yes, no, or true, false form. And let me do this. If touching, and then there's this little drop-down menu. I can parameterize it. If touching the edge, let's do something like that. So if touching edge, let me go back to motion. And how about, why don't we just turn around 180 degrees? All right, so forever, move 10 steps. If you're touching the edge, turn 180 degrees. And that's not the end of the program, because you're in a forever block. So it's going to go again and again and again and again. So let's see what happens. OK, a little buggy, but kind of cool. And we can add to this some silly things that aren't all that intellectually interesting. But if we hit this little microphone button, ouch! All right, let me clean this up. Let me enhance this, as they would say on TV. Clean that up, save, and now go back to scripts. And now let me go to sound. Oh, let me give it a name. I'll call this ouch. And now play sound ouch. Notice it appears in the little drop-down menu. And let's say, ouch! 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 But we can change this on the fly. We can be twice as annoying. Ouch! 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 Or if we make it like 1,000 steps at a time. Ouch! OK, so we're going to leave that one alone. So again, building blocks, right? I started with something super simple, and then I added a feature, added a feature, added a feature, and I no longer need to worry about how the first of those features was implemented as I continue to layer things on top. So in fact, let me do one other here. Let me go ahead and open a file that I brought in advance called sheep. So it has a slightly different character that looks like this. And you know what? Let me see if I can't do something using a counter in this case, a so-called variable. I'm going to go ahead and under events, let me get a green flag clicked. Then let me go to data, which I know from just playing around before is where variables are. And I'm going to go ahead and drag this. So a variable called counter. And I'm going to initialize it to 0. I could call it anything, x or y or z. But in programming, calling something in a semantically useful way, like counter, that describes what it is just a lot easier to read your code later. Let me go ahead and get a forever block here. And let me go to the looks page and do a say block. But what's cool about variables is I don't have to just type in something like hello world, which we've already done. I can instead go to data and drag my variable. And even though the shape doesn't quite look like it should fit, it will grow to fill. And I'll just say the counter for 1 second. Whoops, spoiler, he's going to count. We'll say it for 1 second. Then I'm going to go ahead and have him wait for 1 second so it doesn't count up too fast. And then lastly, change counter by 1. In other words, increment the counter by 1 additional value and do this forever. So the sheep, too, like a programmer, counts from 0. And if we wait long enough, he will do this forever. But that's not exactly true, because in fact, as we'll discover in week 1, integers and computers more generally technically have only a finite, well, rather, computers, when they represent integers, only have a finite number of bits. Right? Those light bulbs there can only count so high before you're out of light bulbs. And a computer, too, only has so much memory, only has so many transistors, so it can only count so high. So it turns out that the sheep, I think, can count to like 2 billion or something pretty big, so we're not going to wait for this to happen. But eventually, some bug will happen that can have some very real-world ramifications. But beyond the sheep, that just introduces a variable. Let's go ahead and open up something I made in advance here called pet the cat. Pet the cat over here. And notice here, it's a few blocks. But when green flag clicked, forever do the following. If you're touching the mouse pointer, so the cursor on the screen, the arrow, play sound meow, and then wait 2 seconds. And just do this forever. Just constantly wait to see if the pointer is, if the cat is touching the pointer. So I hit play, nothing's happening. But as I move the cursor over the cat, and if I move it away, not petting the cat anymore. So some conditional logic nested inside of a loop. How about this example, deliberately called don't pet the cat? What's this going to do? Why should you not pet the cat? Okay. So this is an example of an if-else, right? It's a decision point, and because it's sitting in the loop, they're both getting checked. Is this true? Is this true? Is this true? Is this true? And eventually, one of those is going to apply, and so you hear either the meow or the roar of the lion in that case. Well, let's do a slightly more fancy one that I made in advance to threads. So a thread is just some one thing that a computer can do. So a multi-threaded program is a program that can do multiple things at once. And all of these examples thus far have had just one script, so to speak, one program like this up here. But notice this program has two sprites, two characters. One is a bird, one is a cat. And notice when I click on these down at left, they each have their own scripts or programs associated with them. And both of those programs, notice, start with when green flag clicked. And let's look at the cat. When green flag clicked. And so indeed, when I hit play now, two things are going to happen at once. The cat and the bird are both going to operate simultaneously to create this effect. And you might imagine what's happening. There's a loop, and the bird and the cat are in a loop. The bird is just bouncing like I was before when I said ouch, but the cat clearly has an advantage. There's another sensing block that points the cat deliberately to the bird, in this case here. So we could tease apart by looking through those blocks what's happening, but the key ingredient here is, one, the bird, so that this game isn't completely boring, or this animation, starts at a random direction. And the computer's picking a number between 90 and 180, essentially, so that it's a slightly different animation each time. And then notice here, if the cat is touching the bird, then play the lion 4 sound, the roar. But meanwhile, in the bird's palette, we have this. Forever, if not touching the cat, just keep moving 3 steps. And then here's another puzzle piece. If you're on the edge, bounce. So the bird is just kind of minding its own business, just flying around and bouncing. And it's really the cat that had the conditional logic to determine if it had caught the bird. All right, so let's do one other here. This one being called hi, hi, hi. And this one here just does this in a forever loop. But notice, how do we stop this very annoying program? Hit the space bar, because if I do that, the left-hand program, notice, is constantly listening. Is the key space pressed? Is the space bar pressed? And if so, what does it do? It does a very common technique. It sets a variable equal to some value, but it toggles that value. So it appears, based on the shape, I have a variable that I wrote in advance called muted, which just says yes or no. Is the sound muted or not? True or false? And notice I'm saying this. If muted is 0, then change muted to 1. Else, set muted to 0. So just flip the value from 0 to 1. I could have done change it from 2 to 3 and 3 to 2 or 4 to 5 or 4 to 6, but it doesn't matter what numbers I use so long as I keep changing it to the opposite. And most any programmer would just choose 0 and 1, false and true, off and on to represent this. And this is still running. If I hit the space bar again, the program is still running because there's this other script that says forever do the following. If you're muted, then if the muted variable equals 0, so if you're not muted is the logic, if it's false or a no, then play the sound. Because you're not muted, you should play the sound and then think hi, hi, hi for 2 seconds and then wait and do it again and again and again. And so in this way, do we have a way for people to, programs to interact, and they don't have to be as dated as others. In fact, poking around, no pun intended, someone spent a huge amount of time on the internet implementing Pokemon Go in Scratch. It even like geolocates you in Cambridge or Alston here. So if you want to see too, what people can do is this. Very fancy menu. Click on here. This is me with my arrow keys now. I'm going to go after this. OK, click. And now you click the Pokeball. I mean, I think you're supposed to click the Pokeball. All right, so I did that. I can go over here, and this person implemented some more Pokeballs over here, 3 Pokeballs. So we'll post a link to this online so you can play. But notice, They're just some basic building blocks. It looks a lot fancier, and it is. This is impressive and more than we would typically expect, certainly for problem set 0. I have no idea how long this person spent online, but it's all just a loop. There's a sound playing. There's some kind of loop listening for whether I'm hitting the up arrow or the down arrow or the left and the right, and then if so, it's moving it some number of pixels. And then if I click on another sprite, there's some kind of if condition there. Yeah, this is getting too intense. We're going to stop. It's all those basic building blocks. There are no other ingredients other than the ones we've looked at already. And yet here, let me do one final set of examples that paint a picture, too, of what you can do here. Here's a very simple program that just does this. Cough, cough, cough. And based only on what we've looked at thus far, where's the obvious opportunity for improvement? This program is correct. It coughs 3 times, which is what I intended. But it's poorly implemented. It's badly designed. Why? Yeah, it's not a loop. And it's not so much that it's not a loop. It's that there's a lot of redundancy. There's copied and pasted code, so to speak. And the solution probably is indeed a loop. So let me go ahead and improve upon that. And I'm just going to drag these over here. Let me go ahead and get a repeat block. Change this to 3. I'm going to throw away some of those blocks. And you'll notice it's pretty intuitive. You drag and drop and things appear or disappear eventually. And I can just drag this in here. And now I have a cleaner version still. But you know what? There's this opportunity now for abstraction, to start to define new vocabulary that MIT didn't anticipate. There's wait and repeat and forever and if. But what if I want to introduce the word cough as a block? What if I want a puzzle piece whose purpose in life is to cough? Well, let's look at this version here, which I made as follows. Magically, I have created this puzzle piece here, which Scratch allows you to do. And indeed, C and Python and JavaScript are going to allow you to do this as well. You can create your own custom pieces that you call what you want. In this case, cough feels like a reasonable definition. And then with these pieces down here, can you define what it means? I dragged and dropped from this palette here, more blocks, this big purple block where I typed in cough as the name of my new puzzle piece. And then I'm saying anytime a user calls this new cough puzzle piece, do a say and a wait. And so up here in my repeat block, I can just cough 3 times. And I would argue, especially if now you kind of hide this detail, like who cares how cough is implemented? All I care about as a programmer that I can cough. I don't care how say is implemented. I just care that the cat can say something. I can abstract away that detail and only focus on what's on the screen here. But I can take this one step further. Notice that here I have implemented the loop 3 times. But what if instead I grab this version? And what if instead in this version here, I just change my puzzle piece to take an argument, an input unto itself. And that input can be a number like 3. So now if I am writing a program and I want the cat to cough, I can actually tell the puzzle piece how many times to cough, because at the bottom here, a fancier version of these custom puzzle pieces lets me specify that cough actually takes an input, takes an argument like this. And you know what? Maybe I realized, wait a minute, coughing is fundamentally the same idea as sneezing. It's just a different word on the screen. I can abstract away further and implement this final version of a cough, which at first glance is way more complex looking. But notice what I've done. I have now genericized really, this puzzle piece to be called say word n times. And now I have 2 new puzzle pieces down here, define cough n times. And what does the cough function do? What does my custom puzzle piece do? It just calls the say block, passing in the word I want to say, passing in the number of times I want to say, because now I can implement sneeze by simply saying achoo, in this case, some number of times. And so I'm layering and layering. And again, the key here is not how I implemented it, but the fact that if I just literally move these off the screen, look how simple, if not pretty, my program now looks, because it does what it says. I've abstracted away what is inside that black box. It happens to be a purple box here. But I've abstracted away what's inside because I don't care how it works. I just care now that it works. And indeed, in problem set 0, this is exactly the kind of layering of ideas you'll have the opportunity to explore. It's exactly the opportunity to apply problem-solving techniques to what's probably an unfamiliar environment. And whether you've not programmed before or programmed before, you'll find that there's a little something in this environment for everyone. And with problem set 1 in a week's time, we'll be transitioned to focusing on a higher level language called C, or rather a lower level language called C, that's even more powerful, even though it's a little more cryptic at first glance. And you'll realize per today's TLDR that this problem set has a shorter window of time than future ones, simply because you should find it fairly accessible, and not to worry if you add the class late. We'll address that before long. And before we adjourn for cake, let's finish with just a 2-minute look at what awaits you here in CS50.
On me, I go to you.